All right. This video right here is going to pick up the cumulative review, 17 through whatever is left on the page. All right. So starting off right here, cosine of 15. You use whatever you want right here, cosine or sine. Excuse me, addition or subtraction. All right. Just make sure it equals 15 degrees. So with this one though, you gotta use subtraction. Because there are no angles that can add to give you 15 degrees on the unit circle. So let's do cosine of 45 minus 30. So that gives me cosine of 45, cosine of 30 plus sine of 45, sine of 30. Now, if you look at a unit circle, you'll see that 45, for 45, you have the point radical 2 over 2, comma radical 2 over 2. And for 30, you have the point radical 3 over 2, comma 1 half. So cosine of 45 is radical 2 over 2. Cosine of 30 is going to be radical 3 over 2. Sine of 45 is radical 2 over 2. And sine of 30 is 1 half. So you multiply this, you get radical 6 over 4 plus radical 2 over 4, which is radical 6 plus radical 2 over 4. Alright. Over here, sine of 345, since I did subtraction here. I did subtraction there, I'll do addition here. So sine of 345, we can say is 300 plus 45. All right, so now 300, that point is going to be 1 half negative radical 3 over 2. And 45, of course, is radical 2 over 2, comma radical 2 over 2. So we have sine of 300 cosine of 45 plus cosine of 300 sine of 45. All right, so that's going to give us sine of 300 is negative radical 3 over 2. Cosine of 45 is radical 2 over 2. Plus cosine is 1 half of 300, and cosine of 45 is radical 2 over 2. So now we're going to multiply those to get a negative radical 6 over 4. And we're going to multiply that over 4, so that gives us negative radical 6 plus radical 2 over 4, or radical 2 minus radical 6 over 4. As long as that negative is attached to that radical 6, like that. All right, we got a radian. Let's convert that real quick. I'm going to do it over here on the side. We got 5 pi over 12 times 180 over pi. All right, that gives us 5 times 180 divided by 12. That's 75 degrees. Now, 75 degrees, I know you're thinking 30 plus 45. Don't do this. And the reason being, all right, I'm going to star this for you. Do not use 30 degrees. All right, there's an error that's made right here that people don't account for, and they consistently mess this one up. Do not use 30. When doing tangent, do not use 30 degrees. I repeat, when doing tangent, do not use 30 or pi over 6. Don't use it. It's the same thing, radian, degree. Don't use these for tangent. find another angle. All right, so let's make 75 another way. All right, let's do subtraction. All right, so how about 120 and 45? We'll do 120 minus 45 because that'll give me 75. Again, with tangent, do not use 30 degrees. Do not use 30. Do not use 30 degrees. I don't know how much more clear to make that. Do not. Write this down so when you do it, you do not use 30 for tangent. For tan. Do not use 30. Okay. I think you got it. So 120 minus 45. So real quick, let me write that point down for 120. 120 is, all right, 120 is negative 1/2. 120 is negative 1/2 radical 3 over 2. And of course 45 is radical 2 over 2 comma radical 2 over 2. So tangent of 120, if you do sine over cosine, you have sine over cosine. So you keep change flip. I'm sorry, that's a negative right there. Times a negative 2 over 1. The 2's cancel. The negative's still there though. So this will give me negative radical 3. This is tangent of 120. Right here, tan of 45 equals 1. Sine over itself. This over itself is 1. So now when we do it, since we did subtraction right here, we have tan of 120 minus tan of 45 all over 1 plus tan of 120 times tan of 45. So 120 is negative radical 3. This is 1 all over 1 plus negative radical 3 times 1. Right? So 1 times a negative radical 3 is a negative radical 3. Plus 1 minus radical 3. So we have negative radical 3 minus 1 all over 1 minus radical 3. There is your answer right there. Don't do this. Do not use 30. You'll mess up. It'll mess you up. Right here, tan of 195. All right, let's think here. How about 135 and 60? All right, 135 and 60. So real quick, tangent of 135. Well, let's look at that point real quick. 135 is going to be, sorry, I gotta change this line. All right, so 135 is negative radical 2 over 2, radical 2 over 2, and 60 is 1/2 radical 3 over 2. So now tan of 135 will be that over itself, but with a negative, so negative 1. And tan of 60 is sine over cosine, which we keep change flip. So flip this bottom, right? It's just radical 3. This makes it so much easier, guys, when you don't use 30. Just don't use 30. All right, don't use 30. Now let's jump in here. Since this is addition, you have tan of 135 plus tan of 60 all over 1 plus, about to make a mistake, 1 minus tan of 135 times tan of 60. Right? So anyway, this is radical, this is negative 1, sorry, tan of 135 is negative 1, plus tan of 60 is radical 3. And then we have 1 minus a negative 1 times radical 3. So when we go ahead and simplify this, we end up with negative 1 plus radical 3 all over that. Negatives become a positive. So 1 plus radical 3. Boom. Answer right there. Right there. Again, do not use 30 degrees for tangent, okay? It will mess you up. All right, let's keep going. Right here, simplify. Okay, simplify or verify. First, notice simplify versus verify. All right. This one, see how this doesn't have an equal to sign? This is just an expression. We're going to simplify this one. See how this one has an equal to? That means we want to make this left side equal the right side. This is verification. This is verified. This is simplify over here. Okay? Okay. Back at it again. We need to expand these. So let me make this big so I have space to write. All right. So we got to expand this first. All right. So I'm going to do this one in green. All right. So we have sine of pi, cosine of x, plus cosine of pi, sine of x. And then we have this minus sign right here. So I'm going to put that minus sign back in black. And then I'm going to expand this other side right here in blue. All right, so cosine, you have cosine of pi, cosine of x, plus sine of pi, sine of x. Now, why did I put parentheses around this side, guys? Because you have to distribute the negative, all right? So distribute the negative. We have sine of pi, cosine of x, plus cosine of pi, sine of x, minus cosine of pi, cosine of x, minus sine of pi, sine of x. Now, let's look at pi. The point pi is negative 1, comma 0, right? So right here we have sine of pi. Well, that's 0. So that's 0 times cosine, right? Cosine of pi is negative 1. So that's negative 1 times sine of x. Cosine of pi again is negative 1 times cosine of x. And sine of pi is 0. So 0 times sine of x. And now I reduce this, so 0 times cosine doesn't exist. Negative 1 times sine is negative sine of x. Right here, negative is a positive, so positive cosine of x. And then 0 times sine of x is 0, so that's 0. So there we go, that's what we're left with. All right, we simplify. Not verifying again because there's nothing equal to. All right. Okay. All right. For this next example right here, I don't know how this mark got over here. All right. So this one is a verifying problem. All right, because we have something equal right here. So I'm going to expand this again. So I'm going to do cosine of theta, cosine of 30, minus, because ooh, didn't mean to do that. Shoot, that's annoying. All right, sorry about that. So we need to go minus right here. So cosine of theta, cosine of 30, minus sine of theta, sine of 30, minus, and I'm going to go ahead and expand this one all the way out too. Why did I put the parenthesis? Because of the negative right here, the minus sign. So sine of theta, cosine of 60, I didn't mean to do that. Cosine of 60 plus cosine of theta, sine of 60. And we said this equals negative sine of theta. Now, real quick, we need 30. 30 is the point 1, 2, 3. Radical 3 over 2, 1/2. 60 is 1/2 radical 3 over 2. So we have cosine of theta, cosine of 30. Well, remember, cosine of 30 is going to be radical 3 over 2. So radical 3 over 2 times cosine. All right, and then we have sine of 30. Sine of, wait a minute. Cosine of 30. All right, sine of 30. Sine of 30 is 1/2. So minus 1/2. This is 1/2. So 1/2 sine of theta, right? All right. Now I have the minus. I still haven't distributed this. Let me go ahead and distribute this now. So we have sine of 60. Sine of 60, cosine of 60, excuse me, cosine of 60 is 1/2. So minus, because we distribute the negative, so minus 1/2 sine of theta, because cosine of 60 is right there. All right, and then right here, you have sine of 60, which is that, but it's going to be negative because you distribute the negative. So negative radical 3 over 2 cosine of theta. Now we said this equals negative sine of theta. Now, let's see, can we cancel out anything? Absolutely. Radical 3 over 2 minus radical 3 over 2. All right, that's 0. And then you have negative 1/2 minus 1/2. So negative 1/2 minus 1/2 is negative 1. So that means this is negative 1 sine of theta. And we're trying to verify that equals negative sine of theta. And yes, this is the same thing. So this is verified. All right, that's verified. All right. 23 here. 23 says, given sine is 20 over 29 in quadrant 2. So we have quadrant 2. So 1, 2. So quadrant 2 triangle would be like this. All right, just think about it like that. Right? Quadrant 2. So quadrant 2 for quadrant 2 of theta is sine is 20 over 29, right? So Pythagorean theorem, negative 21. I'm just going to go ahead and do that out, right? How'd I get that? 29 squared minus 20 squared. It's going to give me equals 441. The square root of 441 is 21 and negative 21. But because this is on the left side in quadrant 2, that's a negative, right? And then it says, right here, it says sine of B is negative 8 over 10 in quadrant 3. All right, so B is in quadrant 3, so quadrant 3 is down here. All right, for B. And they said that cosine was negative 8 over 10. Cosine negative 8 over 10. So we do Pythagorean theorem again. So 100, that's 100. That's 64. So 100 minus 64 is 36. Square root is 6 and negative 6. We want negative 6 because this is below the x-axis. Think about quadrant 3. That's below the x-axis. So there you go right there. So now it says find the exact value of cosine theta plus beta. So remember, this is going to be cosine theta, cosine of beta, minus sine of theta, sine of beta. So cosine of theta is negative 21 over 29. Cosine of beta is going to be negative 8 over 10. Sine of theta is 20 over 29. Sine of beta is negative 6 over 10. All right. Now, this is going to give me, let let's see, 21 times 8. This is going to be, well, negative times a negative is a positive. So that's 168 over 290. 10 times 29 is 290. And then right here, we have basically a negative times a negative. So that's going to be positive anyway. But 20 times 6 is 120 over 210. All right, so 168 plus 120 is going to give me 288. Oh, why did I put 210? I'm sorry, y'all. That's 290. 290. So 288 over 290. Does that reduce? Yep. You could put 144 over 145. This divided by 2 is that. That divided by 2 is that. So 144 over 145. All right. Let's keep going. So for this one, let's see if I can put all this on my screen. All right, cool. So cosine of theta equals negative 7 over 25 in quadrant 2. So again, quadrant 2, we have this right triangle right here of theta, and that's going to be cosine is negative 7 over 25. I'm going to do Pythagorean theorem to figure out the rest of this. So 25 squared is 625. All right, 625 minus 49 is 576. And the square root of that is 24. So this is going to be a positive 24 because that's above the y-axis. Now, this one, right, this one is in quadrant 1 for beta. So everything's positive. So 3 sine opposite over hypotenuse 3 over 5. This is going to be 4. 25 minus 9 is 16. The square root of 16 is 4. So find sine of theta plus beta. So that is sine of theta, cosine of beta minus cosine of theta, sine of beta. So sine of theta is 24 opposite over hypotenuse 24 over 25. Cosine of beta is adjacent over hypotenuse. So 4 over 5. Cosine of theta is negative 7 over 25. And sine of beta is 3 over 5. Wait a minute. Yeah, 3 over 5. Yeah. So we got 24 times 4. That's 96 over 125. This is going to be a positive 21 over 125. That's going to give me 117 over 125, like that. Yeah, 117. All right, let's keep it going. Right here, sine of theta is in quadrant 3. So quadrant 3, there's my triangle. All right, theta is sine is opposite over hypotenuse. 100 minus 36 is 64. 64, the square root of 64 is 8. So I got negative 8. Why negative 8? Because if this is the y-axis, on the left side of the y-axis, that has to be negative. And then right here, also in quadrant 3, so let me draw another one. We have for beta, sine is opposite, negative 5 over 13. Remember your hypotenuse, guys, will never be negative. So that's 169 minus 25 is going to give me 144. The square root of 144 is plus or minus 12. We want the negative 12 because, again, y-axis, we're on the left side of the y-axis. So now find tangent of theta plus beta. So you're going to have tangent of theta plus tangent of beta all over 1 minus tangent of theta times tangent of beta. Well, tangent of theta, remember tangent is opposite over hypotenuse. So you have negative 6 over 8 plus negative 5 over 12. Negative 12, excuse me. Negative 6 over negative 8, all over negative 5 over negative 12. All over 1 minus negative 6 over negative 8 times negative 5 over negative 12, like that, right? So the top right here, I'm going to punch this in my calculator. I'm going to do 6 over, this is positive 6 over 8, right? The negatives cancel. So 6 over 8 plus 5 twelfths. So on my calculator, 6 divided by 8 plus 5 divided by 12. Math fraction, no decimals, 7 over 6. Down here, I'm going to punch this whole thing in my calculator too. I'm going to do 1 minus 6 divided by 8 times 5 divided by 12, math fraction, 11 over 16. Again, no fractions. Now, keep change, flip this right here, or just do it in your calculator. So 7 divided by 6, divided by 11 divided by 16. All right, and that's going to give me math fraction 56 over 33. 56 over 33. Okay. All right, keep it rolling. 26. All right, sine of 4 over 5 in quadrant 1. So quadrant 1, everything's positive. Here we go for quadrant 1. Sine is opposite over hypotenuse. 5 squared minus 16 squared. 5 squared is 25 minus 4 is 16. So 25 minus 16 is 9. Square root of 9 is 3. All right, and then we have quadrant 3. They told us tangent is opposite over adjacent. So both of those are negative, by the way. That's why this is positive. Negative over a negative is positive. The thing about it, beta, opposite has to be negative because it's down here. And this has to be negative because it's over the left side of the y-axis. So anyway, 13 squared plus 5 squared will give us 194. And the square root of 194 is 13.92. That's a tangent, right? Tangent is 5 over 13, opposite over adjacent. Yes, so this equals, wait a minute. Boom, 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 boom. Actually, do I even need the Pythagorean theorem right here? No, I don't, because I don't need the hypotenuse. I don't even need the hypotenuse for this one because I just need tangent for this one. So anyway, tangent of theta minus beta is going to be tangent of theta minus tangent of beta all over 1 minus tan of theta, tan of beta. So tangent of theta is going to be 4. So tangent of theta is 4/3 minus tangent of beta, which is 5 over 13, all over 1 minus tangent of theta times tangent of beta. All right, and I'm just going to punch it in my calculator. So when I do 4/3 minus 5 over 13, math fraction, that gives me 37 over 39. And then right here, when I do this whole bottom, 1 plus, excuse me. Whoa, I see I wrote that wrong. Minus, that should be a plus, shouldn't it? Hopefully you caught that. That should be a plus. So 1 plus 4/3 times 5 over 13. That gives me math fraction, no fractions, 59 over 13. Over 39, sorry, 59 over 39. All right. So now, this one, I'm going to just keep change, flip this one. So 37 over 39 times 39 over 59. See, that's why I keep change, flip this one. It gives me 37 over 59. So 37 over 59. Right there. All right. Or you could just, again, punch that in your calculator, math fraction. Right there. Okay. All right. We're almost there. 4 more real quick ones. Simplify or verify. Remember, you only verify if you have an equal to. So this is a simplify. This is a simplify. 29 and 30 will be verified. All right, so I'm going to expand this one. By the way, pi halves is the 0.01. All right, so I have sine of pi over 2 cosine of x minus cosine of pi over 2 sine of x. So sine of pi over 2 is the y value, so 1 cosine of x. All right, and cosine of pi over 2 is 0, so 0 times sine of x. All right, and 0 times sine of x is 0. So I'm just left with cosine of x. All right, this one, these are all variables. So sine of a, cosine. You know what? I need more space. Let's move over. All right. So I have sine of angle A, cosine of B, plus cosine of A, sine of B, plus sine of A, cosine of B, minus cosine of A, sine of B. So does anything cancel out? Does anything look the same with a positive and a negative? I have a positive cosine, or negative, cosine of A sine of B. Do I see another cosine of A sine of B? Yeah, right here. So that's that's negative, that's positive, that's going to cancel. And so now I have sine of A cosine of B plus sine of A cosine of B. So 1 sine of A cosine of B plus 1 sine of A cosine of B gives me 2 sine of A cosine of B. All right. Now the verify. Remember, verify has an equal. The other two we simplified. This we verified. All right. Pi real quick. Pi is the point -1, 0. And pi halves is the point 0, 1. Now, cosine. We have cosine of pi, sine of theta. Oop, wrong. Cosine of pi, cosine of theta, plus sine of pi, sine of theta. All right, plus, and that's the expansion for this one. Cosine, cosine, sine, sine. Now for sine, we have sine of pi over 2, cosine of theta, minus cosine of pi over 2, sine of theta. So cosine of theta, cosine of pi is -1, so -1 cosine. So negative cosine. Sine of pi is 0, so 0 times sine. Sine of pi over 2 is 1, so 1 cosine. And then cosine of pi over 2 is 0, so 0 sine equals 0. So now check this out. Negative cosine plus cosine of theta is 0. And 0 times sine minus 0 times sine is 0. So 0 equals 0. Verified. All right, for this one, we got pi over 4. And remember, pi over 4, that point is radical 2 over 2, radical 2 over 2. All right. So we have cosine of theta, cosine of pi over 4, plus sorry about that. This is me trying to get through the video so it's not so long. So I have sine of theta, sine of pi over 4, and then this, we have that minus, and then we have this side. So we have cosine of theta, cosine of pi over 4, parentheses, because of the minus, minus sine of theta, sine of pi over 4. So now let me distribute the negative real quick. So that is going to give us a negative cosine of theta, cosine of pi over 4, and that's going to be plus sine of theta, sine of pi over 4. Now, cosine of pi over 4 is radical 2 over 2, so this would be radical 2 over 2 times cosine of theta. This is radical 2 over 2. Then I have a plus right here. So this is going to be, this is radical 2 over 2, so you have positive radical 2 over 2 sine of theta. Then I have this minus right here, so this is radical 2 over 2. So radical 2 over 2 cosine of theta. And this is radical 2 over 2, so radical 2 over 2 sine of theta. Now we look to see if there's anything we can cancel out. All right, I have a negative cosine of radical 2 over 2. Negative radical 2 over 2 cosine of theta, and positive radical 2 over 2 cosine of theta. That's 0. So now I have 1 radical 2 over 2 plus 1 radical 2 over 2. Well, I have common denominator, so I just add that at the top. So that's 2 radical 2 over 2 sine of theta. And that must equal negative 1. So right here, that cancels. Right? Wait, does it say verify the identities? Simplify or verify? All right. This shouldn't be a verify, guys. Let me go ahead and clear this up. Hey, add this to the directions. This should be solve, not verify. So solve that. So that cancels. So I have radical 2 sine of theta equals negative 1. Now, the reason I rewrote this as verify is because, it's solved, not verified, is because these don't equal each other. All right, this won't equal negative 1. So let's go ahead and just verify it, because you'll have problems like this on your deal. All right. So I have radical 2. And so now you have this sine of theta equals negative 1 over radical 2, which we can rationalize to have negative radical 2 over 2, right? So where does sine equal negative radical 2 over 2? Well, let's look at our unit circle real quick. So let me flash this unit circle up here. So where does sine equal negative radical 2 over 2? Sine, the y value. Well, here, sine is negative radical 2 over 2. And here, the sine value is negative radical 2 over 2. You see it? 5 pi over 4 and 7 pi over 4. So theta equals, what would we say? 5 pi over 4 and 7 pi over 4. Okay? So those are the solutions right here. All right. Again, this was not a verifying. This was a solve. All right. Now, that concludes this video, man. Please get on the live sessions if you need help. Hopefully you took detailed notes on these 2 videos I made. They really should come in handy for you when you take your cumulative. All right, because, yeah, you're at home with resources. Catch you later.